Hi, and welcome to another SPSS tutorial. This tutorial is going to be a really quick overview of how to do correlations in SPSS. So we're going to use a data set here that is supposed to depict the different factors related to the number of albums that a band sells. So the factors that we've got in the data set, or the variables that we've got, are their overall record sales, and then their advertising budget, an airplay variable which represents the number of times their song was played on the radio within 1 week, and a variable representing the attractiveness or the perceived attractiveness of the band. So when we're doing a correlation, we're interested in knowing whether there is a relationship between two continuous variables. All right, so all of the variables in this data set are continuous. We could really do correlations between any of them. Let's start by just looking at a very simple correlation between record sales and advertising budget. So we want to investigate whether these two things have anything to do with each other. So in order to do a regular bivariate correlation, we go up to the Analyze menu, scroll down to Correlate, click on Bivariate. All of the variables in the data set will appear on the left, and whichever variables we want to run correlations for, we just move over to the box on the right. So let's move record sales and advertising budget over to the box on the right. Really, this is all we need to do at this point. There are options to do more specific targeted kinds of correlations that will differ depending on the types of variables that we have. But for the general Pearson's bivariate correlation, which is the most common type of correlation we can run, we don't really need to do anything. So click OK, and you get one box in your output, very simple. And so this box lists all of the variables that you've selected for correlations. It will list each variable in its own row and each variable in its own column. And so each of the boxes that appear in this correlations matrix represent the intersection of the variables in the rows and columns. So you'll notice you get some duplicate information, you get some information you don't need. So we've got 4 boxes here. 2 of them have a Pearson correlation value of 1 here. So this first row represents the correlation value, or the correlation coefficient, which would be the R value. So a value of 1 means a perfect correlation, and we'll almost never see that in the real world, but you'll see it all the time in your correlation analysis, because this represents the correlation between a variable in itself. Right? So anytime that you correlate a variable with itself, it's going to have a perfect correlation, but that's not something meaningful that you would look at in real life. So we can just ignore these boxes that have the 1s in them. So the other 2 boxes actually represent the same information. So this first box in the upper right is the correlation between record sales and advertising budget, and the box in the lower left is also the advertising budget and record sales correlation. So it's the exact same information. So really you get 4 boxes here, and you only need the information from one of them. So if we look at one of these boxes, we get 3 pieces of information. The first row is the Pearson correlation coefficient, the R value. So that represents the strength and the direction of the correlation. The significance value, or the P value, is the second row. So that tells you whether or not this correlation is significantly different from 0. And the last row is the sample size, the number of pairs of observations that this correlation is based on. So for this specific correlation that we've run between record sales and advertising budget, we have a R value, or a Pearson's correlation coefficient, of 0.578, which is a positive correlation. It's a fairly strong positive correlation. The p-value is less than 0.001, so this is a significant strong positive correlation, and it's based on 200 pairs of observations. So 200 different participants had measurements for both record sales and advertising budget, and this correlation coefficient is based on those 200 different pairs. All right? So in a nutshell, that's all we need to do with correlation coefficients. The one other thing that I'll show you is that we don't have to do correlation coefficients one at a time. So if we go back to our correlation analysis, we can move all of the variables over into the correlation box if we want. Click OK, and we just get a whole table of all the possible correlations between every every potential pair of variables that we've got here. So we've got 4 variables. So we've got 1, 2, 3, 4, 5, 6 different unique correlations that we can examine between those 4 variables. And if we scroll through, we can see the correlation values for all 6 of these. We can see that all of the variables were positively correlated with record sales significantly. So all of the correlations associated with the record sales variable all have p-values less than 0.05, so these are all significant. None of the advertising budget was not positively correlated, or was not significantly correlated at all with the number of air plays on the radio or the attractiveness of the band, so these correlations are not significant. But the number of plays on Radio 1 in the given week, so the amount of airplay that the song received, was positively correlated with attractiveness of the band. So this is just an easy way to run a whole bunch of correlations at once and skim through your results. And remember, you only need to look at about half of the information here. All of the correlations in the other half of this table are the exact same values that we get in the top right quadrant here. Okay, so that's a really quick overview of how to do correlations in SPSS. Pretty easy stuff. So check back with the other tutorials for the different other kinds of analysis that we're going to be investigating.